Hey guys, this is Mr. C, and in this video, we're going to talk about recursive sequences. Hopefully you've already watched my videos on arithmetic and geometric sequences because these are going to be a lot like those. So we're going to get right into it with some problems here. And it says, John has 16 seashells. Each day he collects 7 more seashells. Write a recursive sequence, A sub n, to model the situation. Very common kind of a problem on EOC. And so here's how we do it. We have our A sub n is the name of the sequence, equals. Now this right here, you're adding 7 each time to the 16 to begin with. This is arithmetic. And so this one is arithmetic. However, we want to write a recursive sequence. And so we need to make sure that we mark that up. Recursive sequence. So how does that look like? Recursive sequence that's also arithmetic. All right, so here's what we do. We say A sub n minus 1. That stands for the previous term, okay? So what we're going to do to get the next term, we're going to take the previous term and we're going to add 7 to it. So each time we're going to add 7 to the previous term. Now, what was the first term? The thing about recursive sequences, and these are used a lot in computer science, the thing about these is you have to have 2 pieces of information for these. You only needed 1 for this, one explicit expression. This one you need 2 of them, and we also need to know what the first term is. A sub 1 is equal to, and the first term here is the 16 seashells that he begins with. So here's what's going on here. So we have the term number 1, and the first term is 16. The second term, we're going to add 7 to that. So 16 plus 7 turns out to be 23. The third term of this sequence, you just add another 7 to that, right? And so if you add another 7 to that, you get 30. The fourth term, add another 7 to it, and you get 37, and so on. And so that's just the first 4 terms of this sequence. It is arithmetic, but if you want to write it recursively, then you're going to have to write it this way with these 2 pieces of information. Students will forget this one all the time, the second one. Or they'll try and take these 2 concepts and they'll try and merge them together into one big weird looking thing, and you can't really do that. So each time I'm going to be noting whether the situation is arithmetic or geometric to kind of clue you into that. All right, so these were the 2 things that we needed for this. So if I was to like box something in, like on my exam or something like that, then it would have to be this guy right there, just to show you. And it would have to be all of this right here. I would box in. So all of that in red box is my final answer in the red box. All right, let's take a look at our next one. Our next one is this one. And it says that Mike has $600. Sounds a lot like a beginning amount. And it says that each day he spends $40 on gas and food. All right. It says to write a recursive sequence, A sub n, to model the situation. If he spends $40 on gas and food every day, he's subtracting $40 from 600 over and over again, right? So our sequence this time is again arithmetic. Now, if I was actually writing an arithmetic sequence for this, the common difference would be negative because it's going down by 40. And as a matter of fact, the common difference would be negative 40. The first term would be 600. For recursive, we start with A sub n equals. We write A sub n minus 1 for the previous term. And then what we're doing is we're subtracting 40 each time. But again, I don't know what the first term was where I started. And so I have to tell people my first term, and that would be the 600 right there. And again, you could, keep going down and down and down until you got down to 0 when he doesn't have any money left, as a follow-up question to that. But if all you had to do is write the recursive sequence, this is it right there, and we are done with that one. All right, here's our next one. A photocopier can enlarge an image in increments of 25% each time a copy is enlarged. So that just means it's taking a little picture and blowing it up each time. Every time you press the button, you make another copy, it keeps getting bigger. So it says a certain image has a width of 4 inches. Write a recursive sequence, A sub n, to model the situation. So what we're doing is we're writing a sequence to figure out what the width of the new picture is going to be if you enlarge it. And so if we enlarge that, here's what's going on with this one. This one is actually geometric. So the reason why it's geometric is because every time you press that button on the copier, it's multiplying the dimensions of the previous picture or image by 25% more than it was before, and it's being multiplied. So it is geometric. So a sub n is equal to, okay, so now we have our last term, n sub 1, but we're going to enlarge it by 25% each time. So we don't want a 0.25 in front. We don't want to add or subtract it because we're not adding to it, we're multiplying. So instead of 25%, what we really want is 1.25. So it's multiplying it by 1.25, the previous term, every time. And so now I need to put that previous term here, a sub n minus 1. So for geometric sequences, if you want to write it recursively, it is multiplication going on each time, and that's exactly what's happening here. Again, we have to put down our first term, and that was the 4 inches right there, and then we can figure out what the next ones are going to be. So for instance, if you take 4 times 1.25 and you press that button on the photocopier, the very next time you get an image, it's going to be 5 inches for the width because you're multiplying that by 1.25. Again, if you do that one more time, the next image is going to be 6 1/4 or 6.25 inches wide because you're multiplying each time by 1.25. All right, our next one says the number of bacteria in a culture doubles every day. There are currently 3,000 bacteria in the culture. Write a recursive sequence, a sub n, to model the situation. So n this time is going to be referring to the number of days, right? And that's kind of obvious from the problem, not minutes, not years or seconds, but since our unit of time is in days, it's going to be in days. But, you know, that's something to talk about. So we have 3,000 bacteria in there, and it's going to be doubling. When that implies it's multiplying by 2 each time. And if it's multiplying, it is geometric. So in our recursive sequence, we should see some multiplication going on. So a sub n is equal to, okay, so there's 3,000 in there already. It's going to double every day. We don't want to put 3,000 here because then it's going to multiply each day by 3,000. That's not what's happening. They're doubling each day. So we're going to multiply by 2 each time, the previous term. So 2 times, we'll put a little dot there, 2 times the previous term is going to double it each day. So we also have to still put down our initial amount, first term, and that's where the 3,000 goes. And then that's it. That's all you have to do. All right, here's another one that, that appears. And it's the so-called Fibonacci sequence is a recursive sequence that begins with 2 1s. To obtain the third term, we add the previous 2 terms together. So what's happening is it starts with 1, 1. To get the next one, you add these 2 previous ones together to get 2. To get the next one, you add the previous 2 together to get 3. To get the next one, 3 plus 2 is 5. And you can keep going like this. 1, 2, 3, 4, 5. Next one would be 5 plus 3 is 8. 8 plus 5 is going to be 13. 13 plus 8 is 21. 21 plus 13 should be 34. And how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And one more. 34 plus 21 should be 55. And it keeps going and going and going like that. So it says to write the first 10 terms of the sequence, and then we're also supposed to write a recursive sequence that represents the Fibonacci sequence. So this time, here's our first 10 terms. That's already done. To get those first 10 terms, though, okay, we call this an order 2 recursive sequence because it starts with 2 different terms here, or 2 terms, and both of those are required to get the next one. So that's called an order 2, or second order recursive sequence. So here's what happens. A sub n is equal to a sub n minus 1, which is the previous term, plus the one right before that would be a sub n minus 2. That's 2 back. 1 back, and then that's the one we're talking about now. So if we add the 2 previous ones, we get the next term, and it's going to generate term after term after term, just like we did here. Now that's it. That's all we need to do, because the 2 previous ones are here, and then there's your next one. And so this time though, since it is a second order recursive sequence, we have to also list a sub 1 is 1, and we have to list a sub 2, because if we don't know these, we're never going to be able to plug anything in here to begin with. And so the second term was, it says 2 1s and a 1 right there. So these are very common. This is actually a special case of what's called the Lucas sequences. And so you'll study those in discrete math courses or courses in college. If you take number theory and so on, those come up, or combinatorics, they'll come up. So an interesting thing right now when we talk about recursive sequences, just in case somebody decides to give you a challenge problem. And so those are recursive sequences, pretty simple. Remember to like and share, subscribe to my channel if you haven't already, and we'll see you guys later. Bye.